Math 2, Unit 10 and 11. Unit 10 and 11 was all about how to graph quadratics and then solve them. So the first part, the very first page is, do you remember how to graph these quadratics? And the first way we learned how to graph quadratics was called vertex form. And so if you remember, we learned way long time ago that the form for a vertex form was where there was an opposite. I'm going to put a little arrow here, opposite, and I'm going to put a little same right there next to that. Because h and k was a negative h and a positive k, if I want to know where the vertex is, it was opposite of whatever's happening to the x. It was the same as whatever is outside of the squared term. H and k would show you where the vertex is. And so if I remember that, when I look at f of x here is x plus 2, the quantity of x plus 2 squared minus 3, then I can figure out what the vertex is by doing the opposite of this plus 2. And the same thing as whatever's happening outside of the squared term. The opposite of positive 2 is negative 2. That's your x-coordinate of your vertex. That is the y-coordinate of your vertex. So if I go to the left 2 and down 3, this is where the vertex is of that function. The next thing we can look at is the a value. The a value here is a positive 1. The positive 1 tells you that the graph opens up. It also tells you whether it's wide, narrow, or normal. Because this a value is a 1, it means it goes to the right 1, up 1, and to the left 1, up 1 for the first unit only. So as I look at that, I know that this parabola is going to do something like this as it's graphed. It asks you, what's the domain of the function? What can you plug in for x? And if you look at this, I can plug in any value I want for x. There's going to be an x value for anything. There's an x here that's going to be on the graph. There's going to be an x here that's going to be on the graph. There's going to be an x here that's going to be on the graph. There's going to be a part of the graph on any x value we want. Even a negative 100. You can plug negative 100 in. You can find out what the y value is. So for my domain, it's all the x values or all real numbers. Whereas the range is different. The range is what are the y values? We only have y values that are bigger than something because they go upwards forever and ever and ever. The y values, when I look at the lowest point, since this is a minimum, and the minimum point is negative 3, the y values have to be greater than or equal to negative 3. What that says is basically we have y's that are here and above. If the parabola was going downward, we would switch this sign. It would be less than if it was going down. The line of symmetry is the line that cuts this graph right down the middle. It's a vertical line. It's always at x is equal to whatever h is. So the line of symmetry here would be at x is equal to negative 2. It's the same thing as the x-coordinate of your vertex, and it's x equals. Sometimes this is called the equation of the line of symmetry, by the way. Is the vertex a maximum or a minimum? That is a minimum value because there's a bottom only. There's no top. It goes forever and up, 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 and forever. It doesn't have a highest point. It only has a lowest point. So that is how we graph when it's in vertex form. Then part B is going to ask you to do the same thing. There'll be a difference because there's a negative a value, so it's going to open down. It's going to have a different vertex. It's It's going to be opposite same, but you're going to graph that. You're going to do that as well. I'm not going to touch the rest of that. You guys can work on part B. I want to jump to number 2A, because what happens when it's in standard form? Standard form is ax squared plus bx plus c. So when it's highest degree to the next to the constant. This one's in standard form, x squared minus 2x minus 8. And what they ask you to do is to complete a chart. And so they're going to ask you to plug in 4. What do you get? What do? I plug in 4 squared minus 2 times 4 minus 8. And I see, what do I get? I get 0. I'm going to do the same thing. I'm going to plug in 3. 3 squared minus 2 times 3 minus 8. And see what I get. I get negative 5. All I'm doing is taking my calculator and typing in 2 squared minus 2 times 2 minus 8. And get negative 8. 1 minus 2 minus 8. Plug in 0. I can do that in my head. 0 minus 8 is negative 8. Plug in negative 1. I have a feeling that when I plug in negative 2, I'm getting 0, and I can figure out the other values as well. Last one, negative 4. Negative 4 squared is 16 minus 2 times negative 4 minus 8. So I fill out the chart. I might as well graph it. 4, 0. 3, negative 5. 1, 2, 3, 4, 5. 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, negative 9. 0, negative 8. I'm just taking these points and plotting them. 1, 2, 3, 4, 5, 6, 7. So I can already see that I'm going to have sort of my parabola like this. It asks, where's the vertex? Vertex is the lowest point or the highest point. The bottom of the parabola or the top. In this case, the vertex is at 1, negative 9. Then they ask, what's the line of symmetry? Well, the same as before. It always goes through that x-coordinate. What is the line of symmetry? It's what x is equal to whatever that value is. That x-coordinate, x is equal to 1. Now, if I want to know how to get the line of symmetry from the equation, there is a formula for it. I am almost positive you may have forgotten by this point. So I'm just going to remind you. The formula to get the line of symmetry when it's in standard form is x is equal to, does anybody remember?
0.
Nope. Negative b over 2a. If you've forgotten, the formula to find the line of symmetry from the equation is x equals negative b over 2a. I believe, I'm not sure, but I'm almost positive that any formula that we had throughout the unit will be put onto a formula sheet and you'll be given that for your final. The final is not do you know your formulas? The final is, do you know how to use your formulas? So I'm pretty sure that this would be on a list for you. I will confirm that and let you know by next class whether you get a formula sheet or not. I think all Math 2 teachers are going to do that too, by the way, here at Buchanan, just so you know. So let's just double check. Opposite of B would be, instead of -2, we would use +2. X equals +2 over 2 times A. A is 1. 2 over 2 is X is equal to 1. Yeah, it works. It's the same value. Then it asks, what are the x-intercepts? Where does it cross the x-axis? So I'm going to put an x-axis right there and go, what is this value? 4, 0. What is this value? -2, 0. Those are our x-intercepts. Where's the y-intercept? It crosses when x is 0, y is -8. What's nice about standard form is the c value, only when it's in standard form, is the same thing as the y-intercept. And then if you were to factor this, x minus 4, x plus 2, this times that is -8, and 2x and -4x makes -2x. That multiplies to be that. You could see how this factor and this factor equaling 0 would show you that these are where the intercepts come from. What is the relationship between the factors and the x-intercepts? If I take this factor and I set it equal to 0, I can actually add 4 and figure out that my x-intercept is where the factor is equal to 0. If I put the factor, what's the relationship between the factors and the x-intercepts? You can find what the x-intercepts are by setting the factors equal to 0. That's what we're doing in part D. So we talk about how to graph vertex form. We talked about how to graph standard form. Now what about translations and so on? If you're supposed to graph x squared is just a normal size parabola that goes through the vertex. X squared goes through 0, 0. It goes to the right 1, up 1, to the left 1, up 1. And then it says sketch a translation of Rx such that xy goes through translation that all the x's add 3 and the y's subtract 2 to create t of x. Well, what does that mean? What that means is you're taking this parabola and you're going to the right 3 units for your x's. You're adding 3 units. If I add 3 units to 0, 0 in the x direction, I'm going to go 1, 2, 3 to the right. If I subtract 2 from the y, I am moving it 2 down from there. To the right, 3 down 2. It's the same parabola. This is t of x. T of x would look like this. And I'm going to put t of x right here. T of x. This one is r of x. And this just translate it. What does it mean descriptive form? It means to the right 3 units and down 2 units. The first half of Unit 10 was all on graphing. I'm hoping that reviews with you how to graph. Then we had some problems that dealt with factoring, setting equal to 0, and how to find average rates of change and things like that. So let me remind you how to do that. This is 4, and I'll do 4a. Find the average rate of change for this parabola x squared for x is equal to 2 to 5. Well, these are your inputs. This is like your x1, and this is like your x2. We want to know how much is it changing by when x is 2 and then when it goes to x is 5. So if you know that this is what you're plugging in for x, what do you get for the y? If you plug the 2 in here, 2 squared, what do you get? 2 squared, you get 4. That's the y value. I'm going to call this y1. 4 is equal to y1. Now if I plug in 5 into that equation, you get 25, and I'm going to call that y2. We're going to use those two numbers to figure out how much is it changing by. How do we figure that out? We do y2 minus y1 over x2 minus x1. Formula that you will be given. I'm going to take 25 and I'm going to subtract the y1 value, 4, and I'm going to divide by x2 minus x1. So I get 21 over 3, which means that the average rate of change is going to be 7 units. It will be different from 5 to 8 because the curve is going to be steeper. I would expect this to be a bigger number from 5 to 8. I'm not going to do that one for you, but how are you going to do it? This will be your x1, this will be your x2. Plug it in to find out what your y1 and your y2 are, and then use the formula. After that, you had to figure out how to find solutions for x. How do we do that? You set things equal to 0, you factored. Sometimes it was GCF factoring. Sometimes it was difference of squares factoring. This one, I've pulled out a 2 because 2 can go into both. I pull out an x plus 3 and x minus 3 because that's a difference of squares. Since this all multiplies to equal 0, well, 2 can't equal 0. What about x plus 3? Can that equal 0? Sure. What about x minus 3 equaling 0? There are two solutions here when x is negative 3 and when x is positive 3. My two solutions for 5a are plus and minus 3. Easiest way to write it. 2 can't be a solution. 2 will not work. Sometimes you're going to factor that way. Sometimes you're going to factor by doing guess and check. When you're dealing with 18, you have a lot of choices. 1 and 18, 2 and 9, 3 and 6. 4 doesn't work, 5 doesn't work, or 6 and 3, or 9 and 2, or 18 and 1. And we're trying to get to negative 15. Let me see. 2 and 1. Let's try, that's 12 and 3. What if I used this times that is 12, and this times this is 3. 12 and 3 would make 15. If I had the 2 times a 6 and made that negative, and a 1 times a 3 and made that negative. When I'm doing guess and check, I'm trying to find a product where 2 times this is 12x, and this times this is 3x, and together, if those are both negative, can make the negative 15 by checking this outside and the inside. Last times the last equals that. I definitely have found how it factors. This times this equals 0. Either 2x minus 3 equals 0, or x minus 6 is equal to 0. In this case, x would be 6. In this case, 2x plus 3 divide by 2, x would equal 3 over 2. So my solutions here are 3 over 2 and 6. you may need to review your factoring for the questions on section 5. The last two things I want to remind you are, on the last page near number 7, I want to remind you about completing the square and the quadratic formula. When you complete the square, we learned a lot of different steps of how to complete the square. This is 7a. You may have forgotten how to do this, so the first thing that you do when you're completing the square is you move the c value. And then you leave 2 underscores, I think is what we called them. Let me make sure you can see that. You add 6, and then you leave a blank space. And then what you do is you make sure your a value is a 1. If it's not, you have to do a GCF. And then what we do is, since a is 1, I need to add half of this squared. I need to add a -2 squared, which means we're adding 4 to both sides. I'm adding 4, I'm adding 4. On this side, 6 plus 4 is 10. On this side, there's no reason to multiply that out because it's going to factor perfectly into a quantity squared. It becomes x minus 2 quantity squared equals 10, because x minus 2 times x minus 2 would be x squared minus 4x plus 4. It works. And what they're asking you to do here is they're asking you what's going to go in the box. If you already have the minus sign there, the 2 goes in the box. What will the combined total be? It will be a 10, will be your answer. We learned to go further than that, to square root both sides, keep it in radical form, plus or minus, and then move the 2. If you were to keep going, just so that in case you ever wanted to use this technique, you would square root, and then there'd be a plus or minus value. These would just reduce, and then you would add the 2 over. This is a way to find solutions that are not whole numbers. Completing the square is a good technique if you get stuck on things. And then if there's the quadratic formula, this will be our last one. And it's in standard form. We should know how to plug things into standard form. The quadratic formula, -b plus or minus radical b squared minus 4ac over 2a. Well, what does that look like? The opposite of b, the opposite of -5 would be a +5 when you simplified it. But I'm going to put in the -5 because it says the opposite. -b, opposite of b, plus or minus b squared. Same thing as -5 times -5 squared. Minus 4. Oh, I just realized something, but minus 4, 4ac all over 2a. 2 times a. So I plug everything in. It's only at this time that I actually went back up and I read my directions. And my directions say, fill in the correct numbers by solving and completing the square quadratic formula. And then it says, then solve the equation. So remember earlier how I said keep going? That's what our answer is supposed to be on the line. 2 plus or minus root 10. I'm kind of glad I did that. I just forgot to answer the question and not just figure out what goes in the box. Which means down here, we do have to simplify it. What I'd recommend that you do is use the fraction button on your calculator. Negative, negative, do that in your head. Plus or minus you can't put in. Just do the positive one first. Square root of Negative 5 times negative 5 is a positive 25. Minus 4 times 3 times negative 1 over 2 times 3. My calculator can simplify the positive value. And I'm curious, if I change it instead of the positive value, if I go to the negative value, if the answer is just going to have a minus sign in between. It probably does. So the negative will just bring a negative sign there. So my final answer here, 5 plus or minus root 37 over 6. I hope that reminds you how to do everything. There's a whole lot of stuff in this unit. If you get stuck or you have questions, let me know. We're going to stop your notes right there.